shaft of diameter 10 millimeters is supported on two flexible bearings 0.5 meters apart and carries a rotor of mass 5 kilograms at the center of its span. What is the whirling speed of the system, and what will be the deflection of the shaft when the angular speed is 10 revolutions per second? The eccentricity of the rotor relative to the center is 0.05 millimeters, and we're told that the elastic modulus is 200 gigapascals. Okay, and the equation for static deflection is this. Okay, so this is what we're given. Diameter of the shaft is 10 millimeters. The mass at the center point is 5 kilograms. There's an eccentricity of 0.00005 meters. Shaft is rotating at 10 revolutions per second, and the length of the shaft is 0.5 meters, and we're given this equation. Okay. So the first thing, looking at this, we have the mass, we have the length, we have 48, we have E, we need to get I. So I is the moment of inertia. So the moment of inertia for the shaft I is pi d to the power 4 all over 64. So when we put that into the calculator, we get the moment of inertia to be 49 by 10 to the power of minus 10. Let's just do it on the calculator. So here you have on the calculator, so it's pi, d is 10 millimeters, which is 0.01 meters. So pi by 0.01 to the power of 4 all over 64. And when I do it, I get 4.9 by 10 to the power of minus 10 meters to the power of 4. Okay, so once we have I, we can get the deflection D. So M was 5 kilograms, we were given that. The length of the shaft was 0.5. 48 is just 48. We were given E, 200 by 10 to the power of 9. And we have the second moment of area now, 49 by 10 to the power of minus 10. When we put that into the calculator, we get 0.133 meters. Okay, so when I put it into the calculator, that's what I get. That's my answer in meters. I'm just going to multiply that by 1,000 to bring that to millimeters. 0.132. Okay, so we get roughly 0.133 millimeters. So if I have the deflection, I can get the frequency, which is 1 over the square root of deflection. So I'm putting this back in meters. So it's 0.00133, and that works out to be 43 hertz, or 43 revolutions per second. The deflection then is equal to the eccentricity, which was 0.00005. We were given that. The critical, now this critical frequency is normally given in radians per second, but the question gave us the rotational speed in revs per second, which is a frequency. So frequency f, omega is equal to 2 pi f. So you can consider it like 2 pi fc by 2 pi f. The 2 pi's would cancel, so it's just the same as fc all over f. So the critical frequency, which was 43, all over this, which is 10. And when we put that into the calculator, we get 2.86 micrometers.